Okay guys, we've been talking about the interior angles of a polygon, like the 3 angles in a triangle or the 4 angles in a quadrilateral. We learned that the sum of their angles is going to be the rule where you take the number of sides of the polygon and you subtract 2 from it, right? So you take the number of sides of a polygon and subtract 2 from it. That number, remember, tells us the number of triangles that we can make in a polygon. So if we do that one vertex deal, so given like a 5-sided shape, we can make 3 triangles in it, right? And then we just take it times 180, because each triangle has 180, and that's how we find the angle sum. If we're talking about a regular polygon, and since each angle is the same in a regular polygon, then we just take our sum times 180. That's our sum, right? And then we just divide by the number of angles, which is still equivalent to the number of sides that the polygon has. So for every side, there's an angle for it, right? So we have these rules where we can find what one regular angle is in a polygon. We can also find the interior angle sum. But now let's talk about exterior angles. Exterior meaning on the outside. So I'm going to grab my polygon tool. Here's a triangle. Here's what an exterior angle is. And all an exterior angle does, and I'm going to grab my ray tool, is extends one side of our polygon. So if we look at the extension of one side, like say this side here, notice it creates an angle on the exterior. So this is an example of a exterior polygon. If I continue and extend our sides, notice we get 3 exterior angles, this one and this one. Okay, so these are exterior angles of a triangle. So for every angle in the triangle, there's going to, or in the polygon, there's going to be an exterior angle that goes with it. Okay, so if we knew, for example, I'm going to turn my rounding here to whole numbers. Let's say that this angle right here is 93 degrees. So we could actually figure out what this angle is, right? Because this angle plus this angle should equal 180 because they make a straight line, or they're linear pairs of each other, right? So these are linear pairs, so they should add up to 180. So if this is 93, all we have to do is subtract it from 180 and get the other angle, which I believe is 87 degrees, right? This exterior angle here, if I know that this angle, for example, is 47 degrees, then again, this exterior angle will just be 180 minus 47, which is a 133 degree angle. Now, we could use the angle tool and measure this angle here, or if I know that this is 47 and this is 93, and I add those up, the sum of these two angles, let's see here, 90 plus 40, looking at the tens, 90 plus 40 is 130, and then 3 plus 7 is 10, so 130 plus 10 gives us a sum of 140. So we automatically know that this angle should be 40 degrees, right, because the angle sum is 180 degrees. So let's check it just to make sure. Hey, check that out, 40 degrees, right? This angle right here is 40 degrees, which then makes this exterior angle here 140, because again, these two angles have to add up to make a straight line, which is an angle measure of 180 degrees, okay? So that's all that exterior angles really are. Even if I had, say, I don't want to delete that. I'm going to delete my pen strokes, though, and I'm going to delete my polygon. If we had, say, a quadrilateral, it's the same idea, right? We could find out what some of these angles are. We know that the sum of these 4 angles in a quadrilateral add up to 360 degrees. And we can do some exterior angle measurements, okay? Now, what about the sum of exterior angles? Well, I'm going to extend my... I'm going to grab my ray tool again, and I'm going to make my 4 exterior angles. Okay, so these guys here. And I'm going to go ahead and make the angle kind of stick out here. So I'm just putting points on my rays so that I can measure angles. So each ray is going to need an additional point so that I can just go, like if I want this angle measure, G, B, A, and then E, A, D, FDC. I'm just curious what these 4 angles add up to. So one way we can think of this is like, we have this quadrilateral, this picture right here in front of us. It's kind of like if we were to take this and put it on a stand and start walking backwards. And the further that we walk backwards, the smaller and smaller this image becomes. But the beauty of angles, because angles are really rays go on forever. So we can actually see all these angles still, even though as we get further and further away. Let's say that this is in Belgrade here, and we're walking to Bozeman, right? So as we get closer and closer to Bozeman, then this got smaller and smaller and smaller and smaller and smaller. But aren't these right here the 4 angles of that quadrilateral? Right? So even if I made these angles bigger, which it's not going to show that. My bad. But those are the 4 angles right there, right? You can kind of see it, I hope, so that when we zoom out again, there's those 4 angles. And notice, those should add up to 360 degrees. They make a full revolution, right? Let's check out that triangle that I had earlier. So I'm going to do a triangle again. I'm going to do my make my exterior angles. And if I zoom out again, we're going to Bozeman. Notice again, oh man, those angles are going to get in the way, aren't they? For my first one. Sorry guys, bad example, but I hope you can see that those 3 angles, which are these 3 rays right here, maybe I'll make them red. Notice again, they would add up to 360 degrees. And actually, the exterior angle sum of any polygon, if you add up all the exterior angles around a polygon, they're always going to add up to 360 degrees. Even if you had, say, a decagon, right? So, even if we had, let's go a regular polygon here. So I'm going to make 10 sides. So here's a regular decagon. If we were to extend all these exterior angles, I hope it makes sense to you that no matter what our polygon looks like, so here's all of the exterior angles of a polygon. But again, if we do this zoom out thing, check that out. They're all going to kind of, all the angles are going to add up to, again, a full revolution. And that's true in any polygon. So please make sure in your notes that the exterior angle sum, if you add up, so I'll type this here. We'll call this the exterior angle sum of a polygon, okay, is always going to equal, so here we go, exterior angle sum of a polygon is always going to equal 360 degrees, okay? So that's nice. Oh, my little guy's crying here. All right. So let me go over a couple examples here of using some exterior angles in some triangle kind of questions or in a polygon. Okay, so in this picture here, we're going to find this angle measure of x. Okay, so we have an exterior angle shown. We know that this is 122. So we can actually figure out what this angle is right here because, again, this angle plus the 122 make 180. So all we do is take 180, subtract 122 from it, and I believe we get 58 degrees. So we know this angle in the triangle, this interior angle now is 58. This is a right triangle because it's given to us, so we know that's 90. So if we add these 2 angles up, don't they add up to 148 degrees? And so if this is 148 degrees, if we add up these 2 angles, then this angle, when we add it to our sum, should equal 180. So then what number do we add to 148 to make 180? This should be 32 degrees. So just using that exterior angle. Let's find x here. Okay. Now remember, congruent marks mean that this is an isosceles triangle, and this is also an isosceles triangle. So this is also, whatever x is, this angle is going to be the same thing. So these angles are actually congruent, right, in our isosceles triangle because of our reflection concepts, right? So those angles have to be the same measure. So if this is 56, let's figure out what these have to be. Well, the sum of these two, if we add these two up, right, this angle here and this angle here, and we add this one, these three angles, we get 180. So if we already know 1, let's subtract this from our sum. So 180 minus 56 should give us 124 degrees. So we know that these two angles, if we add them up, it's going to add up to 124 degrees. And since there's two of them and we know that they're congruent, wouldn't we, each angle would just have to be half? Just have to be half of 124. So if you half 120, we get 60, and if you half 4, we get 2. So 62 degrees would be each of these angles, right? All right, that doesn't really help us a whole lot, does it? Because that's not in the right triangle that has x in it. But now that we know that this angle right here is 62 degrees, isn't that just an exterior angle to this triangle? So if this is 62 and we add it to this angle, these two angles should add up to 180. So let's subtract 62 from 180 and we get 118. So if this angle here is 118, now because this is isosceles, these have to be the same. So I'm going to take 180, the triangle sum, subtract off the angle that I know, that 118, and we're left with 62 degrees. So these two angles that are the same thing, if we add them up, we get 62. Therefore, each one should be half of our 62 degree sum. So x in this case is 31 degrees. Okay? So those are just a couple problems that I want you to be able to do and see if you can find some missing angle measures based off of some exterior angles that we may know. And remember too that the sum, so if you have a 72-gon, right? 72 sides in some shape. If we add up all the exterior angles in it, remember they're always going to add up to the same sum, 360 degrees. Okay? So good luck with that, guys, and please ask some questions if you are confused.